Hello and welcome to Maths with Jacob. This lesson will focus on Tricky Maths Part 25. The number 101101 is a binary number. Change it to base 10. So if you want to pause the video now, you can solve this problem yourself. Have a think about it and see if you can solve it. I will move on now and we will discuss the solution. So here's your chance to pause it right now if you wish, and now I will move on to the next slide. Now binary means two. The BI, like bicycle, has two wheels. A binary number only consists of two digits, so you'll only ever see a 0 and a 1. So this is a binary number. Now, to change a binary number to a base 10 number, we need to know that the first number here, whatever we have here, whether it's a 0 or a 1, has a value of 2 to the power of 0. The reason we choose 2 is because we are dealing in binary numbers. There are only two numbers to choose from, 1 and 0. The one on the right, that is the first one on this side, when we take those 6 digits into account, this first number here has a value of 2 to the 0, and that's 1. The next digit, whether it's a 1 or a 0, in this case it's a 0, has a value of 2 to the 1. So if there was a 1 here, this would have a value of 2, but because it's a 0, there's no value for this place here. For the next one, any digit there, whether it's a 1 or a 0, we're looking at 2 squared. Because remember, the reason we use a 2 is because it's binary. Now 2 squared is 4. So this 1 here actually has a value of 4. Okay, in base 10. Moving along to the next one. This one here has a value of 2 to the power of 3, which is 8. Over here we have 2 to the power of 4, which is 16, but there are no 1s here. So this place value here really is 0, because 0 times 16 is 0. And over here, the value of that 1 is actually 2 to the 5th in base 10. And 2 to the 5th is 32. So basically we've taken those 6 digits here into account. 1, 2, 3, 4, 5, 6. Now we're going to see what the value of those 6 digits are in base 10. Now computers operate using binary numbers. So if you do some research on binary numbers and how they're used in real life, you'll see that they are extensively used in computer programming. The above table shows how to change a binary number to a base 10 number. So basically what we're looking at is 101101 equals. So we can start on that side. Whenever you see a 1, the value of that 1 is 32. So that's why I've written 32. This 0 times 16 is 0. Because 0 is here, basically it doesn't have a value. It has a value of 0, that's it. That is the value. This one here, so we've already done the 0. This one here has a value of 8, so there's our 8. This one here has a value of 4, so there's our 4. That's 0. 0 times 2 is 0. And that one has a value of 1. So all we do, we just add these up. 32 plus 8 is 40. 40 plus 4 is 44. 44 plus 1 is 45. So this number here has a value of 45 in base 10. And this is a very handy table to use when you're changing any binary number to base 10. You just follow this procedure. And you can do that with any type of number. if you have, for example, base 3 or base 4, basically it's known as modular arithmetic, and you will meet that at another time. But for these binary numbers, which are used in computers, that's how they're solved.